In this episode, we are taking a close look at one of the most important moments in the life of any computer, which is the point where an operating system, OS, gets installed, replaced, refreshed, or arranged alongside another one. New technicians often think installing an OS is a simple matter of putting software on a drive and waiting for a progress bar to finish, but the real work starts much earlier with the decisions that shape whether the result will be stable, secure, and useful to the person receiving the device. A clean install, an upgrade, an image-based deployment, and a multi-boot setup may all place an OS onto a system, yet they exist for different reasons and create very different support outcomes. Once you understand why those methods exist and what problems each one is meant to solve, installation work stops feeling like a random menu of choices and starts feeling like a set of deliberate deployment decisions. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. The first idea to understand is that OS deployment is not just about getting software on a hardware. It is about choosing the right starting condition for the system and the right balance between speed, continuity, control, and risk. A technician may be working with a brand new machine that needs a standard company setup, an older computer that needs to keep user files and applications, a damaged system that has become unstable over time, or a device that must support more than one environment for different needs. Those situations look similar on the surface because they all involve installation, but they are not really the same problem. Good technicians learn to ask what condition the system is in now, what must be preserved, what can be removed, how standardized the result needs to be, and how much disruption the user or organization can tolerate before deciding which deployment approach makes the most sense. A clean install is usually the easiest concept to grasp because it creates the clearest break from the past. In a clean install, the technician is essentially giving the system a fresh start, removing old clutter, past configuration drift, lingering software problems, and many sources of instability that can build up over time. This approach is often the best choice when a machine is being repurposed, when major corruption or persistent performance problems make the current environment untrustworthy, or when a technician wants the highest confidence that old issues will not carry forward into the new setup. The trade-off is that convenience is lower because the existing environment is not being preserved in place. Applications, settings, and user-specific adjustments may need to be restored separately, and that means a clean install offers clarity and control at the cost of extra rebuilding work after the base OS is in place. That fresh start quality is exactly why clean installs are often preferred when technicians need predictability. If a system has been through years of software changes, failed updates, unwanted utilities, conflicting security tools, and user experimentation, it can become difficult to tell which problems belong to the OS itself and which belong to everything layered onto it. A clean install strips away that history and makes the platform easier to trust again. For support teams, that matters because standardization reduces future confusion. A system built from a known, clean state is easier to document, easier to secure, and easier to compare with other systems built the same way. Beginners sometimes resist this idea because it sounds more disruptive, but experienced technicians know that starting fresh can actually save time overall when the current system has become too messy to repair efficiently without carrying hidden problems into the future. An upgrade serves a different purpose because it is designed to move the system forward while preserving more of the current environment. Instead of wiping the device and starting from the ground up, an upgrade attempts to keep user data, installed applications, preferences, and general continuity intact while changing the OS version underneath. That makes upgrades attractive when the user needs minimal interruption or when rebuilding the whole system would take too much time. Upgrades are often seen as the more convenient path, but convenience does not always mean lower risk. Because an upgrade carries old software, old settings, and old assumptions into a newer environment, it can also carry incompatibilities, misbehavior, or leftover issues that a clean install would have removed. The technician's job is to understand that an upgrade is best when preservation matters and the existing system is healthy enough that bringing its history forward is not likely to create more trouble than it saves. This is why technicians should never think of a clean install and an upgrade as a simple choice between hard and easy. The better question is whether continuity is more valuable than reset. If the current environment is stable, supported, and not heavily burdened by years of unresolved trouble, an upgrade may be entirely appropriate and may keep the user productive with less downtime. If the system is already unreliable, full of incompatible software, or built on uncertain foundations, then upgrading may only wrap a new layer around an old mess. That can leave technicians supporting a system that technically moved forward but did not actually become healthier. A thoughtful technician therefore asks whether the current installation deserves to be preserved. That question is more important than whether the upgrade process itself looks faster, because a quicker deployment today can become a longer support burden later if it drags avoidable instability into the new environment. Imaging introduces another deployment method, and its value becomes clear the moment you imagine supporting many systems instead of just one. An image is a prepared copy of an OS environment, often including core settings, approved applications, and a standard configuration that can be placed onto multiple devices to create consistency. Instead of building every machine one piece at a time, the technician can apply a known good starting point across a group of systems. This is especially useful in business, education, and managed environments where standardization matters more than personal customization during the initial deployment. Imaging saves time, but its deeper value is that it reduces variation. When many systems start from the same foundation, support becomes easier because technicians are not chasing a different software history on every machine. The image becomes a baseline, and that baseline improves control, documentation, and repeatability across the environment. At the same time, imaging is not just about copying one machine onto another without thought. A good image must match the purpose of the devices receiving it and the hardware conditions those devices present. If the image includes settings or software that do not fit the target systems, deployment may be quick, but the result may be awkward or unstable. This is why imaging works best when the organization values predictable roles, approved application sets, and a controlled support model. A technician should see imaging as a strategy for scale, not as a shortcut that removes the need for planning. The more devices involved, the more powerful imaging becomes, but only if the standard image is well designed. A poorly planned image can spread the same flaws to many machines just as efficiently as a good image can spread consistency, which means the quality of the base matters as much as the deployment speed it enables. Multi-boot setups solve a very different kind of problem because they are built around coexistence rather than replacement or standardization. In a multi-boot arrangement, one device is configured so that more than one OS can live on the system, with the user or technician choosing which one to start when the computer powers on. This approach makes sense when different tasks, compatibility needs, or testing goals require different environments on the same hardware. A technician might need one environment for everyday use and another for specialized software, training, or compatibility with older workflows. The important point is that multi-boot is not simply an interesting feature. It is a decision to share one machine across distinct operating environments, and that requires careful thinking about storage layout, startup behavior, long-term maintenance, and user expectations because the system is no longer devoted to just one software world. For beginners, multi-boot can sound like an efficient way to have everything at once, but it comes with trade-offs that should be respected. When several OS environments share one device, storage must be divided sensibly, and that means each environment has to live within the space allocated to it. Startup becomes more complex because the system must know how to present and launch multiple choices correctly. Support can also become more demanding because updates, repairs, or changes in one environment may affect the shared startup structure or alter assumptions about storage and access. This does not make multi-boot a bad choice. It simply means multi-boot is most useful when there is a real reason to maintain separate environments on one system rather than one clear primary environment that meets all needs. Good technicians avoid using multi-boot as a novelty and instead see it as a deliberate compatibility and workflow solution with added complexity attached. One of the most important deployment decisions happens before any installation method is chosen, and that is the assessment of the hardware and the intended use of the machine. A system must be able to support the chosen OS in a stable and supported way, which means technicians need to think about processor capability, memory, storage capacity, available space, and the age and support status of the hardware platform. Even when a device can technically run an OS, that does not always mean it will run it well enough for the user's real work. A deployment that meets only the bare minimum can leave the user with a sluggish and frustrating system that generates support calls right away. Good technicians therefore separate possible from practical. They consider not only whether the installation will complete, but whether the resulting machine will perform acceptably, remain supportable, and align with the business or personal purpose it is meant to serve. Compatibility checks matter just as much on the software side. Applications, security tools, peripherals, and specialized business workflows may all depend on assumptions tied to a particular OS version or configuration style. A technician who deploys first and checks later may discover that the user's essential application no longer behaves properly, a device no longer has dependable support, or an important workflow breaks because the environment changed more than expected. This is one reason upgrades must be assessed carefully and why clean installs, images, and multi-boot setups all need planning before use. Each method creates a different compatibility situation. A clean install may require reinstalling and revalidating needed applications from scratch. An upgrade may preserve them, but still expose version conflicts. An image may intentionally include only approved software. A multi-boot system may solve compatibility by keeping separate environments. Support confidence grows when technicians connect deployment choice to application reality rather than thinking only about the OS itself. Another important factor is the relationship between deployment speed and deployment quality. New technicians often feel pressure to finish installation work quickly, especially when many devices are waiting or a user wants the computer back immediately. Speed does matter, but the fastest method is not always the best one if it creates a messy handoff, preserves hidden problems, or ignores what the system will need after the first boot. A clean install may take more rebuilding effort but produce a healthier result. An upgrade may be faster at first, but require extra troubleshooting later if old issues persist. An image may be extremely efficient for many devices, but only if the image was carefully maintained beforehand. A multi-boot setup may solve compatibility efficiently, but create more ongoing complexity. The key lesson is that deployment is never just a race to finish status. It is a decision about what kind of support burden you are creating for the future and whether that burden is acceptable. User impact is another major part of good installation planning because technical correctness alone is not enough. A deployment affects files, applications, habits, access, and the amount of interruption a person will experience before they can return to normal work. A technician may choose a method that is perfectly sound from a system perspective, but still create frustration if the user loses expected tools, faces unfamiliar changes without warning, or must wait through avoidable delays because planning did not include their real needs. This is why technicians ask what must be preserved, what can be rebuilt, and what the user actually depends on every day. A clean install may be the best technical answer, but it should come with awareness that the environment must be rebuilt thoughtfully. An upgrade may protect continuity, but only if the current environment is worth carrying forward. Deployment is therefore both a technical and a practical decision, and the strongest technicians learn to respect both sides at once. By the time you compare clean installs, upgrades, imaging, and multi-boot setups side by side, the main pattern becomes clear. A clean install is strongest when you want a fresh, controlled reset and do not trust the old environment enough to preserve it. An upgrade is strongest when continuity matters and the current system is healthy enough to move forward without dragging serious trouble into the new version. Imaging is strongest when many systems need the same known starting point and standardization will reduce future support complexity. Multi-boot is strongest when one machine must support distinct environments for real compatibility or workflow reasons. These are not competing answers to the same question so much as different answers to different problems. The technician's confidence comes from learning to identify the actual problem first, and then choosing the deployment method that fits it best instead of forcing every situation into a single preferred approach. As you move deeper into support work, Try to remember that successful OS deployment begins long before installation starts and continues long after the first login screen appears. The method you choose shapes stability, compatibility, user disruption, and future support effort, which is why the decision matters so much. Clean installs, upgrades, images, and multi-boot arrangements all have a place, but each one makes a different promise about what will be preserved, what will be standardized, and what complexity will remain afterward. When you learn to connect the condition of the system, the needs of the user, and the purpose of the device to the right deployment method, installation work becomes far more than simply putting software on a drive. It becomes a thoughtful technical judgment, and that kind of judgment is exactly what turns a beginner into a dependable technician.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.